We first of all wanted to say thank you to our two sponsors tonight, Spreadfast and Sentry, both contributed to getting Ben out here for this exciting talk. And something, yes, oh yeah. The applause might be about to get louder because I'm told that Sentry is actually going to pick up a couple rounds of the Ginger Man afterward. So, you want to?
Am I supposed to say something?
You can say whatever. Yes. We keep saying we're going to practice
We're
this.
going to practice it.
Because like Aaron and I had a whole he would just do everything I was saying here.
Are you going to talk about that?
What? Why don't you talk about that?
Well, I don't know what to say, except that we have a code of conduct. It's on the website, awesomejavascript.com. Read it. There's a summary, there's TLDR, which is, be excellent with each other. But that really doesn't cover it. What really covers it is this, which is be really excellent to each other and courteous and thoughtful about people who may or may not be like you. If you have any trouble with anything or any concerns or want to talk about anything, you can find us or email us.
Email, and I'm going to open my Twitter DMs, so you can DM me at Loncy.
My Twitter DMs are already open.
Live life dangerously.
It's pretty terrible, but...
Okay, and so the way things go at Awesome.js is that we, our sponsor gets an opportunity to come up and give a short chat with y'all about whatever they want to talk about. Victor's going to talk for Spreadfast. And then Ben's going to give his talk. We'll take a short break after that, maybe a couple questions before the break, depending on what the vibe is. And then depending on how much time is left, we'll do some questions, have an open discussion, maybe argue about frameworks, and or get rebase, which apparently is a thing that people are fighting about now.
Or how terrible the touch bar is, which is my personal
and then after all that, those of y'all who are interested, we're going to head over to the Ginger Man a couple blocks away, and we can continue the discussion.
But who's here solely because you've heard about this on meetup.com? Shocking. Okay, that's unexpected. All right.
Who here RSVP'd on Meetup? Okay, all right.
Okay.
We're doing some analytics. We want to in the spirit of the web, we're going to track what y'all are doing.
Ben.
Actually,
Victor.
Yeah.
I see I'm so bad at this.
Sorry to upstage you for a second. Hello everyone, welcome to Spreadfast. Thanks for all coming. I love this community, and we're very happy and thrilled to be able to get back to you guys, hosting you guys here. I've been to Awesome.js for probably about 5-6 years now, and it makes me very happy to see this many people here. But Spreadfast, we have all sorts of great technology. We use cutting-edge React and backbone, and all sorts of good things too. But anyway, cutting-edge backbone is the thing. It's trademark. But there's a couple of us around that will be staying here after the Ginger Man, so come find us, and figure out what we find out.
How's everybody doing? It's pretty hot. I'm not used to this weather. So this is a talk, source maps demystified. We're just gonna, let's open this up. Who's using source maps today? Okay, cool. That actually seems like most people. Thank you so much, Lon. So what this talk is about is not like an introduction to source maps. I think people probably at this point kind of vaguely understand what they are and how they're useful and why we use them. What this is more of like a deep dive into source maps. Yes, we'll like go through kind of like an example of why they're useful and why you should use them, but also we're going to manually parse the source map by hand, try to understand how the format works, and try to like not treat it like a black box technology, but when you're using them in the future, you'll kind of understand what's happening under the hood. Is that cool? Cool. So my name is Ben Vinegar. It's a real name. It's not a crazy punk alias. I go by Bentelgen on Twitter. That's another kind of, that is a nonsense name. And you can see what's going on there. I work for a company called Sentry, and we're an open source company. We produce a piece of software called Sentry that is sort of like real-time crash reporting for your production applications. We have client libraries for pretty much every platform, be it browser JavaScript or Node or anything on the JVM, PHP, etc. it tells you about things that are going broken live in production. I'll talk a little bit more about that over the course of this. I'm also, part of the reason why I'm talking about this is not only do I work with source maps with Sentry, where I've contributed code there, but I've also worked on this tool, which is a source map validator. It's at v2.sourcemaps.io. There's actually sort of like an older version of this tool that already exists, but this is a new version that's a little bit better. You can take a look. It's at v2.sourcemaps.io, and you can kind of plug in a production source map URL, or sorry, like a JavaScript file that you want to make sure that your source maps are working, and it'll tell you if anything's broken. So that's all I got to say about me and why I'm vaguely qualified to talk about this today. But I want to take us all the way back, get away from source maps, and talk about how do we use JavaScript today. So at Sentry and in my job, like I'm writing, what you might call a modern dialect of JavaScript, which is ES 2015 or ES 2017. I've kind of lost track these days. And JavaScript has some really cool features today. For example, this is a kind of like a pretty simple add function. It takes an arbitrary number of arguments that you can pass this function. It then sums them up and returns 0. It's relatively simple, but it uses some like modern features of the language that exist today. Arrow functions, I'm guessing, are probably like a relatively familiar thing for most people. This also uses a REST argument, or sorry, a REST sort of like REST syntax for specifying like an array of arguments. And then this is also using like new ES 2015 module syntax. So who's writing code like this today? Okay, so this is probably like half the audience, probably more. Of course, I'm still working on a tool that targets some older browsers, relatively modern browsers, but not everything in that example is going to work. So I have to take that code and I have to run it through a tool called Babel, which I'm sure many people are familiar with, which is going to add some extra preamble and sort of like convert this code so it's going to run in sort of like older browsers that I'm targeting. So you can see how the export keyword has kind of changed a bit, and we have this like preamble at the top. That REST operator that expanded the number of arguments has changed into this loop through arguments and arguments.length. And the arrow function has also been changed, right? Of course, just to kind of like keep this contrived example going, I don't actually just run my code through Babel and send that to browsers. I also use Webpack to bundle everything up and serve it along with some other code so that it's everything just kind of runs. But Webpack produces like a lot of code that I don't necessarily want to ship to users, like all these comments, which are really cool for debugging Webpack and trying to understand where all my modules went, but I don't actually want that. So finally, I go through like a final step where I send this code. I send it through a minifier like Uglify, but maybe you've used Closure Compiler or Prepack, which is new, and then it ends up looking like this. Does this all seem like a very familiar process to everybody? I assume that it does. This is like something we've done in the JavaScript world for a long time, right? So somebody famous once said that JavaScript has become the assembly language of the web. And I'd heard that for a couple years, and I never really knew who to attribute it to. I kind of just thought it was something that Brendan Eich said, creator of JavaScript. Seems like something he would say. Also, there's something called WebAssembly or assembly.js. I don't really pay attention too much these days, but it seems like something he would say. But it was actually, this is like a really kind of old quote. I think it goes all the way back to like 2010 or 2011. It's by a blogger named, yeah, it's really old. But it's by a blogger named Scott Hanselman, who maybe you've seen on Twitter or on his blog. And he's actually like a .NET ASP blogger. And he was just kind of making a comment that when he opened his favorite websites, this was, I guess, google.com around the time of the old days of 2010, 2011. He was commenting that the JavaScript code that he saw embedded here, it was obvious that no human was writing this. It was so minified and so compiled that, it bore a better resemblance to assembly than it did to JavaScript. And I think that commentary was pretty apt at the time. And just as like sort of an exploration for when I was experimenting with these slides, like I started writing C and I started experimenting with compilers and seeing what assembly looks like. So this is some assembly. This is actually some C code for an add function that looks very similar to the JavaScript I showed you in the beginning, compiled down. And this is what assembly looks like if you've never worked with like a compiled language. And like, what is this? So these are just machine instructions to the CPU to do stuff like move a value from a memory location into a register, do an add operation on that register, move that value to some other memory location, jump to another location in the application memory space, etc. And so I always get tripped up if this GIF is going to run or if I got to hit like one more. Okay, there we go. So you can actually try to debug this. Like, you can actually run this command in the terminal, and obviously I've experimented with this, and you can attempt to debug it. You know, for a simple function like an add, for a simple like add function, this is like, you know, you can maybe get a sense of what that assembly is doing. But for anything that's like, you know, more than just an add function, it's really hard to understand what this assembly is really doing. And of course, what I'm trying to say is like this is not too dissimilar from what we're doing today, where we take this original code and we run it through all these sort of like compilation and minification steps, and what we're left with is something, you know, variable a equals jf, c equals ne. Like, I don't know how to read that. I don't know how to step through it. I can kind of guess at it, but again, like for a relatively complex application, it's really hard to debug. So I also want to highlight that minified, sort of like minifying your code this way, and sort of not just minifying, transpiling, minifying, etc. It goes beyond just sort of debugging in the browser. Like, there are other tools. Sentry is one of them. What we do is, like, when you have a runtime exception in your production application, you generate a stack trace. We capture that stack trace. We throw it up into Sentry. It's got like a dashboard. We show you what that exception looks like. But if it's minified code, one of the goals of Sentry is to help you understand what is broken by showing you the stack trace. But if it's just a garble of minified code and single letter variables, it's going to be really hard to understand. So just to try to explain, this goes beyond just debugging the browser. So compiled languages like C for the longest time, this is like a solved problem with debug symbols. If I try to compile that C application, which I didn't show you, but you can just imagine that it exists, again with this like dash dash debug flag, and I take a look at what the compiler has generated, not only do I get my output function, or sorry, my output file, which is just add, but I also get this dsym folder as well, which is dsym is just short for debug symbols. If I run the debugger that you saw earlier now with this sort of like debug symbol folder, it's a way better experience. I can set breakpoints on locations in a file, on certain lines. I can expect variables. Basically the kind of thing that we're used to doing in the browser with unminified code. So debug symbols, they've been around for decades. This is not like a new thing. But what's important is that debug symbols map machine instructions, like the ones you saw earlier with the assembly, to source locations and symbols. But why can't we just take that? Why can't we just apply that to all this JavaScript stuff that we're doing today? And the reason is that JavaScript is different. We're not generating machine code. We're actually just taking a bunch of text and we're generating a different set of text at the end of it, right? And so all the debug symbol formats that have existed in the past were never really made for this problem. And furthermore, the way that we consume JavaScript is by downloading it over the internet, right? Debug symbols are generally not created, like the format was not created so that you could just download debug symbols every time that you want to run some file. The idea is you kind of you compile them, they're there locally when you want to build, right? So there's other constraints about JavaScript and how we consume it for which existing debug symbol formats don't really work. So this is like a kind of a long preamble to obviously what I was going to talk about, which is source maps, right? So source maps is sort of the answer to all of this. So source maps are really just a JSON file if you've ever opened one up. And what they fundamentally do is they map source file locations in an output file to n input file locations, right? The idea is like you can have many different files that come together and generate one file, add.min.js or vendor.min.js. Source maps only deal with file names, lines, and columns. They can be any kind of text. There's nothing about the source map specification that says this has to be JavaScript. So it could be used for CSS or kind of anything. And lastly, what I was touching on earlier is that the format was designed to be optimized for plain text transfer over a network. And we'll see what kind of that means in a little bit. So just a little quick history. Going to bring us all the way back to 2010. So the very first version of source maps was actually designed for a Firebug plugin called Closure Inspector. Does anyone here use Closure Compiler? Yes. All right. So like 3 people. Closure Compiler, you can think of it as like the original Uglified, the original Webpack, if you will. It didn't just minify code. It did module bundling and everything. It was a Google project. And one of the authors of Closure Compiler, experienced the same problem that I just highlighted in 2009, where they were using Firebug, they were stepping through their code, but they realized that code that ran through Closure Compiler, it was pretty impossible to see what was on the other end of that. So only worked with this Firebug plugin. It was revised a couple times over the next couple years. And then sort of Mozilla got involved, so this became like a Google Mozilla thing. And the important thing I want to highlight here is that the last specification from 2011, long time ago, that's the version of source maps that we use today. There's no more modern version of it that exists. And what's interesting is that this is not a specification that you'll find on MDN or WhatWG or W3C. This is actually just a Google Doc. This is the canonical version of the specification of source maps. The way you find it is you just Google for source map spec, and this is the first link, and you can open it up, and at any given moment you'll see there's maybe like a dozen people looking at this, and you can attempt to chat with them. But nobody's responded. So despite the fact that it's kind of this janky specification, it doesn't have like this, there's no, like board behind it or anything. It's still obviously really widely adopted. It sounds like most people here are using them in some form or another. All the compilers, transpilers, Babel, TypeScript, mscripted, optimizers, module bundlers, all the browsers pretty much use them. Sentry uses them. And there's also like a bunch of tools, beyond this that you may not be familiar with. Node source map support is a cool node library that I like to highlight, because what it does is automatically transform any stack traces that you might be logging through any source maps that you might have, so you can see the original form. And that could be cool if you're using like TypeScript with Node or ClojureScript, God forbid. I don't really care one way or another about any of these languages. I just feel like I should throw shade on something. So now that we've kind of talked a little bit like why source maps and where they come from, we're going to walk through actually parsing one. So we're going to take us back, and we're going to go to this add function that we had earlier. And I'm going to ignore, for simplicity, I'm just going to ignore all the other stuff we talked about, and we're going to run this through Babel. If you use Babel CLI, you can specify basically the source maps flag, and this will tell Babel to basically just sort of generate a source map for this file and modify the file so that it points to that source map. So if I run this command and I specify the preset of the browsers that I'm targeting, I'm going to get this dist file, which is what you would typically expect, and then I'm also going to get this .map file. Before I go to the map file itself, I want to touch on what happens to the generated file output by Babel. Basically, it looks the same as it would earlier, but now the very last line of that file is this source mapping URL directive. And I'm just going to go and blow that up. It looks like this. It's just a comment with a hash mark, source mapping URL equals add.dist.js.map. What this is this is a signal to the browser that when it downloads that sort of JavaScript file, where it can find the associated source map if it exists. Pretty much all the tools that you specify how you can locate this. Browsers will resolve this URL relative to the JavaScript file that's currently being parsed, but you could say, you can change what that directive says, and you can make it point to a very specific path. You can also point to a like a fully qualified URL, even located on a completely different domain. So if you want to hide your source maps behind a VPN so that maybe only you and people in your organization can access those source maps, that's something you can do. You can also make them local, right? So you can publish a production JavaScript file that points back to localhost, so that if you are like serving a local web server with those source maps, you can make them available to you, but everybody else will just not really download anything. Furthermore, a lot of people don't know this, but you don't actually have to use this comment directive. You can actually use, there's a source map HTTP header that you can send down with your files to indicate where the associated source map is. Some people can do stuff where, like, if you are on your internal network, then that file will return a source map directive, but people who are outside of the network might not. So that's another sort of like flexible thing you can do. And lastly, again, you can do this with CSS and other file formats. And the source map specification actually just sort of suggests that as long as there's a comment, whatever form that may be, on the last line, if it's /*, sure, it'll work with that as well too. And all browsers kind of just make that happen. So if we just stopped here, right? If we wanted to use source maps and we used that Babel command or a similar command, and we made the source map file available, we're kind of done. There's really actually nothing more to do. You don't need to go further. We don't need to talk about this anymore. And then when I sort of like debug this code, let's ignore how I sort of like got this loaded into the browser, but I could step through it. I could see my original code. Chrome will be so helpful as to like actually translate this to its original variables. Cool. That's it. It's pretty useful. Similarly, Sentry, like we just sort of like, we kind of operate like a browser. So if we see that a source map is available in a JavaScript file that's associated with a stack trace, we'll download that source map, we'll sort of like munge through your stack trace and convert it into a form, like into its original form to help you debug, which is also helpful. So if all you want to do is learn about why source maps are useful, this ends here. But we're going to go further and kind of like open this black box. So first thing I want to ask is, has anyone tried to open a source map file? And was that a pleasant experience? Yeah, okay. So source maps are like often like really large, often megabytes in size, and generally, like depending on what editor you're using, it may crash, or if it's Vim, it'll work correctly. Yeah. I don't even use Vim. I'm just making jokes. I don't care. So one of the reasons that I use this like really contrived add function is if you generate a source map for this using the command that we used earlier, it actually all fits in this entire slide, which is really helpful. So again, source map, it's just JSON. We're going to step through what these individual pieces are. I actually kind of like just added a little white space to make it a little more readable, but this is what Babel would produce. So first thing, this is just the version of the specification. If you recall from earlier, we're on version 3. So pretty much every source map is just going to have version 3 at the very top. The next thing is the output file for which this source map sort of applies, which is add.dist.js. Next is this sources array. And this is sort of like the n input files that went into this output file. And for our example, there was only a single file, which is add.js. But for common production applications, like this could be an array of hundreds or maybe even like 1,000 different files, right? Think about every source file, every vendored source file from React would appear sort of in this array. This next piece is an optional part of the source map specification, but this is actually the inline content of that input file into the source map. This is why source map files can get incredibly large, because many tools, I think Webpack does this, by default, like out of the box, will actually inline all of your source content into the source map itself. And that's why you can get like 10 meg. We've seen up to 30 meg source map files. Why would you do this? The reason is that it just kind of makes things easier, because what the browser will do is, if you don't inline the content into the source map, it wants to try and find your source files. So that means you have to make all of your source files available over the web somehow. And that's kind of like a pain in the ass. So it just kind of makes it easier to just embed everything into one file, into one place. Lastly, this is the intimidating part that is scary, which is this like big mappings thing. And this is sort of where the magic happens of translating this output file back to the input files. And we're going to step through that. So looks like this. It's a little intimidating. We're going to step through it. One thing you should know about this like mappings property is the idea is the way the specification works, and as part of being sort of this optimized format, it expects that when you're going to translate something, you've actually got to process the entire file through this source map from beginning to end. There's no like random access translation here. So we have to begin at the very first line and go all the way to the end. Each semicolon in this denotes a new line. So again, this is supposing that we're going to start at the very top of the output file, and line by line we're going to go through. And wherever you see a semicolon is basically saying, at this point you should step to the next line. So the very beginning of this file, there's 5 semicolons. What does that mean if each semicolon means skip a line? I don't expect you to remember what our output file looked earlier, but if you recall, what Babel does is it actually injects 5 lines that were never really part of our input code. It's sort of like some preamble to kind of get modules working. For that reason, there's actually no associated source code that you wrote that I wrote as part of that add file. So what the source map is trying to tell us is just skip over this. There is no translation, right? It just sort of appeared. Yeah, there's nothing that matches. So we've skipped ahead 5 lines, right? So now we're on line 5. And now we get this, what's called a segment. Segments are obviously these characters that are called variable length quantities. Let's get into that in a moment. So what is QAIGB, right? So this is a variable length quantity, or VLQ. It's actually like a specification of kind of condensing integers that goes all the way back to MIDI. It's like a specification from the 90s. I think it's actually like base 127 encoded. So if you've ever base 64 encoded a number, this is sort of similar. One thing that'll help you understand is that, again, the idea is like, go back to source maps. The idea is we're trying to send things in plain text over a network. So this VLQ value, the whole purpose of it is to represent an integer, an arbitrarily large integer, in as few characters as possible, right? So for single values like 0, 1, -1, we just have a single character. But as the number of, like the size of the integer grows, the number of characters like commensurately doesn't grow as much. So for example, if you look at that 1, 2, 3, 4, 5, 6, 7, 8, 9, that's represented in just 6 characters, and it kind of gets better the more that you go. What's also really interesting about this like VLQ format is that you can represent arbitrarily sized tuples with VLQ without having to add brackets, commas, etc. Right? So that final value, which is a 4 tuple, is just represented with just 5 characters, which is very useful. I don't really know how to process VLQ values by hand. There's actually just like a VLQ library for Node and many other platforms that you can just install if you're curious, which is how I just generated these slides. So if you do want to play around with it, you can check that out. So if we go back to QAIGB, which we saw earlier, what that actually is just a 4 tuple, right? So using 5 characters, this is actually representing 8, 0, 4, 16. Each of these values basically represents part of the mapping, and it's really quickly to see where this is all going to go, right? The very first value, 8, that's the column in the output file, right? The dist file, add.dist.js. And if you're wondering why isn't there any line, it's because we already know the line number, right? We're on line 5 because we skipped a whole bunch of semicolons. Next is the index into the sources array, right? That's the big list of input sources that you might have. And the last 2 values are just the line and the column from that source file. So if I expand this, what this is trying to say is, this is column 8, line 5, in add.js, because we know that there was only a single input file, right? So the value of 0 is just indexing us into that. And then it's line 4 in column 16. So if I actually take a look at my output file and my input file, what this is actually trying to highlight is, this is the output, right? Exports.add equals add, and it's saying, hey, that add identifier actually just maps up to this add identifier in add.js. Okay? So that's the very first kind of segment that it's translated. And you might be wondering, like, well, what about exports? What about that dot? So the source map specification doesn't say anything about like how many identifiers or how many like strings that you have to map from one sort of place to the next. It really just depends on what the tool chooses to encode, if that makes sense. So just to kind of hammer this home, we're going to convert a couple more, just really quickly convert a couple more values. This next value is kind of interesting because it's just a G, right? That seems pretty small. It's probably just a single value, and it is. It's just the number 3. So one thing is like, again, going back to this idea that we're trying to keep values and characters as short as possible, is that these values are all relative to the value that came behind it, right? So this 3 is expected to add it back to what was the number 8 to give us 11. The idea behind this is that it's just to keep numbers small. You can imagine that if you've ever looked at, I'm sure many of you have, like looked at a production JavaScript file, you can get tens of thousands of columns, right? Rather than use large numbers to represent every single column location, we just sort of say, minus 3 spaces, plus 6 spaces, etc. Keeps the values small. Intentionally, this is not a for tuple. It doesn't have the other values. What this is trying to say is that there's a location at column 11, but there is no other location in your input file. So if I take a look at the output code, this is just trying to say, hey, I just want you to know that there's an equal sign here, and there's no concept of an equal sign in our input code. Does that make sense, right? Because we didn't write that. This is just something that Babel kind of injected. Last one, we're going to go back. This is a number 3 again, right? If you remember that G comes back, and now it's GAAA. This is a for tuple that's 3000. We add that. This is where it gets a little funky. You add it to the last time that you saw all of these sort of like column values. So 11 does become 14, and then we add 000 to the other like tuple locations that existed, and we get 14, 0, 4, 16. And you'll notice that if you're kind of cluing into how this works, 4 and 16 didn't change, right? So what does that mean? What this is trying to say is, hey, that add identifier just appears again, and it maps to the exact same location that the last one did. Does this kind of make sense so far? So that's it. I feel like once you kind of like, when you break it down, and you kind of like break down what these VLQ values are, it's like not that hard. If you just kind of kept munging through this, right, line by line, segment by segment, the goal is that you kind of create this in-memory translation table. Generally, when you want to map something from an output file back to the input files, you don't go from the very beginning of that like source map, munge through all the lines, and find the location that you want. Generally, every tool, including browsers, have kind of like stepped through their source code. They just like race through this source map once, generate kind of like a lookup table that's really easy to query, and then from that point forward, you can just kind of say, hey, I'm looking for this location in this output file. What is it? And then generally, like every library will just kind of give you what the answer is. Cool. So the good news is, if you found that kind of upsetting, I kind of did, you never need to actually know it again, because it is kind of like a black box. It's kind of opaque. You don't really need to debug it that often. But if you do want to go a little bit deeper in this, like maybe you don't want to parse things exactly manually, a library that I try to highlight for people is this source-map library, pretty self-explanatory. It's from Mozilla, and it's by one of the authors of the specification. And it's a really good tool if you've ever like worked with source maps and you find that, hey, like I'm not confident that these lines exactly line up the way that I expect. And I feel like a lot of people have experienced that. This is a really good tool to just sort of like put the raw source map values into this library, and you can actually, it will generate effectively like a lookup table, and then you can start looking up different values to verify that they're where you expect, right? Quickly walk through this. You basically just read a source map file, you create what's called a source map consumer. This is just the API of this library, and then after that you can just say, hey, give me the original position for line 6, column 0, and it will tell you where you can find it. So really helpful for debugging. Similarly, I guess I'll take the time to like kind of plug that there's this really cool source map validator, which does other things, like it'll actually tell you if your source mapping URL values resolve or your source map headers resolve. It's an open source project. You can check it out. And I'd be glad to talk about it later. It uses cloud functions, which are pretty cool. I'll talk about that at the bar. So that's kind of the end. Hopefully it wasn't terrible. What did we learn? So source maps are just kind of debug symbols for the web. And it's just like a new format that's designed for efficient transmission over a network. It's really just translating text to text, right? Files, lines, columns. That's why you can use it with CSS to less or Sass or other things. And almost everything supports them today, and I really recommend, if you haven't already, you should check them out. So this is it. My name is Ben. You can find me on the internet. Here are a bunch of resources if you want to check out some of these things. Mozilla's source map library. You can check out sourcemaps.io, VLQ library, and if you want to check out the specification, you can use that bit.ly link too. And that's it. Hope that was okay. Yeah. Do we do questions?
Have you ever seen intentionally incorrect source maps?
Intentionally?
Like
Wait.
say,
Oh.
point to a blank file.
Oh, like as an obfuscation technique?
Sure.
No. That's kind of a neat idea. I don't know how to elaborate on that. Yeah, I mean, I guess you could. I mean, I guess that you could point to a completely garbled source map, right? Just to mess with people. I think that's really the only application of that. Yeah.
The audience for messing with would be like people.
Yeah. Go ahead.
Other people may have also experienced this. Like, if you're like debugging in Chrome and the source map, like the source code appears, you're able to like open the source file.
Mm-hmm.
You set a breakpoint in that, and like Chrome pops open like the compiled file.
Mm-hmm.
Like, what's going on there, and how can I stop that? Or do you, source map?
Yeah. One thing I could recommend is there used to be a time when Chrome would actually show you that it was downloading source maps in the network panel, and it doesn't do that anymore. But you can kind of turn on an internal flag. I can't remember which one, like the network flag thing, and you can actually see whether it's successfully downloading the source map. So that's one thing you can do if you just want to make sure that it's actually getting the right thing. But this sounds like maybe it is. You believe that it is getting the right thing and just kind of like flubs around. I think that that's often the case of just the lines are wrong, is usually my experience. And many tools don't generate the lines correctly, like out of the box. Many versions of Webpack are wrong. That's a problem. If I was a good citizen of the open source community, I'd probably help them out. Uglify is pretty good, but I think that's usually often what it comes down to. Yeah?
If you like babbled in Webpack or Webpack did babble or whatever you're doing, does a source map get generated at each step in Piggyback, or does it wait till the end, or how?
Yeah, so what you're describing is like, I mean, everyone heard, I don't have to repeat that, but if you use a tool like at different spots, will it generate a source map at every level, and will tools sort of like magically follow that? Typically they don't. That's why I do recommend that if you are generating source maps, and if you're wondering why maybe your mappings might be incorrect, which happens all the time, I recommend using a single tool like Rollup or Webpack, even though I kind of made fun of it, and use plugins, right? So typically the way it works is if you use one tool, even Browserify, if you use one tool but use plugins, they typically do sort of like keep all the translations in one place. If you do insist on using separate tools, there are some libraries that will actually string the source maps together. I think it's called, like, one of them is called sourcemap-concat. So that is a possibility as well. But I would recommend just using a single tool if you can. Is there anything? Yeah?
What do people do with what you showed would put your unminified code accessible in production if you just hosted that publicly? What do people tend to do to prevent that?
Yeah, so I'm really lucky because I work on an open source tool. So, and actually we got a security alert where someone was like, I'm a security researcher and I noticed that you've exposed all of your source code via source map, which is fun because I was like, hey, well, like we just have an open source repo where, yeah, it's on GitHub, so I'm not really too worried about that. I think typically you see like the VPN thing, or headers, like sort of like conditional headers depending on where you are at the network. But this is like, that's usually something that you're kind of involving operations or kind of like network people to just kind of make sure that you get the right thing. That's the best answer that I have right now. Like Sentry has we do consume source maps, and the idea is like if we see a stack trace, we'll actually try to fetch your public JavaScript files and look for source maps. But what we can do is actually just push them to us. In which case we don't actually go over the wire; they're just sort of like saved with us. And I don't know that the browser has the same concept. Yeah.
So actually, yesterday morning, I was setting up pushing source maps to Sentry.
You don't have to waste everybody's time with this surely painful story.
So I did have a question. Was how do I improve the docs? And I found the repo for that. But there's one thing that says where it's like, so it kind of implies you upload your source files too.
Yeah.
To the map.
So this is what I touched on earlier, where source maps have this. You can conditionally inline all of your source content into the source map, right? If you do that, the browser, other tools, they don't need to look anywhere else because everything's just in one place. But some tools won't do that, or maybe by default they won't do that. In which case, you need to actually, like Sentry and the browser will need to also additionally kind of find your source files. The source map specification has other ways of doing that too. Like you can effectively say like here's my files. It's sort of like, you remember, let me go back. There's a lot of stuff here.
It's like, part of my question is also, there's a lot of files, and the documentation is just like one post, one file.
Yeah. Okay. So see this like sources array, right? So when you're trying to debug in the browser, first of all, it's like, hey, is there a source mapping directive or a header or whatever? Cool. I'm going to download that source map. Browser opens up your source map and goes, it munges through all those mappings and discovers, oh, I need to also locate add.js. Okay. And if you've chosen not to inline the content, which depends on the tool or your own choices, like for example, if you want to keep that private, the browser will say, oh, in order for me to let the developer step through that file, I need to download it, right? And what it's going to do is effectively try to download it by applying this path relative to where it found the output file. Does that make sense? And so your next question is like, well, that's kind of crazy. Like, am I going to push 1,000 files onto the web? Probably not. And that's why this inline sources content exists. The flip side is that you get source maps that could be 10 megabytes, 20 megabytes, etc. Does that sort of make sense?
Well, I meant more for, would you push all those to Sentry?
We effectively work exactly like a browser. I can talk about this afterwards, but it's, yeah. Cool?
Is there any way to keep the source files versioned with the source maps, or is it basically like you either inline it like this, or you're kind of like stuck with keeping it in sync yourself?
Yeah, I think it's the same. It's the same. How do you version your files that appear in source maps? Again, you can embed them all. It's the same concept if you're versioning any kind of production files. I'm sure many people here have a distinct hash or something that they sort of put different versions of their files on. Maybe nobody's nodding. Okay. The same concept kind of applies, right? You could have each of these paths to these sources could be slash and then maybe MD5 or SHA-1 or something, a hash to that file name. Does that make sense? Right? Or you could embed it in the file name itself, right? Add.abc123.js, etc. Yeah.
I have a similar question. So does Sentry fetch the source map when it receives the crash report?
Yeah, so I really just described Sentry as working like a browser. What that means is the source code that we've written is we look at what the browser does and we really try to replicate the same behavior. So when we see a stack trace and we're like, oh, there's a crash in add.min or app.min.js. So what Sentry will do is effectively, like a browser, try to fetch that file. It'll find a source mapping directive, and like the browser, it'll try to fetch that source map and kind of keep going. Does that make sense?
Yeah.
Okay.
So do y'all ever run into a situation where you receive, like, the source map is changed while the crash report was in transit? Is that something that Sentry just has to be vigilant about?
Yeah, that's a problem. Similar to a browser. That's why we do stuff like try to push those files. You can choose to push the files to us so that they're the version maps up correctly, or you have to do kind of what this fellow suggested earlier, where you have to version every source map, every source file. Make sense? Yeah.
So there's a way to push the source file, right? Like, for example, when I deploy my app, I can also push the source map to Sentry, so it wouldn't be like available publicly, right?
Yes. Yeah.
So, but then you kind of go to add.js and see, okay, it points to some file, but you also have that file which was pushed. So where would you go?
We look in. You can think of like everything that you push to us. We just look there first.
Ah, okay, so that's the curve. Okay.
Yeah. And actually, the way that you name files in Sentry is just the web address. It's basically just saying, you know, that file that you were going to find over here. It's over here. That's it. I can talk more about that afterwards. Oh.
Well, yeah. So let's,
Ben needs a break.
for no reason whatsoever, why don't we take a break? It is 8:34 on my watch, so my watch says 8:40. Please come back within 6 minutes.
Cool. Thanks, everybody.